Hello and good afternoon and welcome to the CIBSE virtual conference on the theme of Net Zero Carbon Climate Emergency 2021. My name is Greg Keeling and I'm the chair for this webinar. Before commencing with my introduction of our speaker, I'd like to thank our 5 sponsors, Atkins, Faithful & Gould, IES, MPS Group and Wilmot Dixon for their support. All the webinars over the 2-week period are being recorded and will be loaded to the CIBSE YouTube channel. The recordings are only available to delegates and CIBSE members, and you'll be sent a link at the end of this conference. If you have any questions during the presentation, please include them in the chat box and we will answer them towards the end of the session. Please do ask questions because it makes the session far more interesting and interactive. This afternoon's webinar is entitled Energy and Emissions Data Drops for RIBA Plan of Use and Soft Landing Projects and will be presented by Dr. Roderic Bunn. Rod has a track record in researching the performance of non-domestic buildings, lectures widely on building engineering and on the role of human behaviour in building performance, and advises building owners and building design teams on the way to ensure design ambitions are achieved in reality. He has authored a number of industry guides and is probably best known for his work on soft landings. Rod's talk will present best practice energy and emission data drops consistent with guidance in the 2021 RIBA Plan of Use and CIBSE 2020 TM61 operational energy performance. Rod, welcome and thank you for supporting our CIBSE conference this year. I know you are experiencing issues with your laptop and you haven't able to get your camera to work. So Rod will be presenting this webinar just audibly. There'll be no, we won't be able to see Rod. So over to you, Rod. Thank you very much.
Thanks very much, Greg. I'm concerned that people can't see the slides. Can someone confirm that they can see the slides?
We can't see the slides.
Okay, so you cannot see my slides. Is that correct?
Yeah.
Right. Sorry, everybody. It's a brand new Apple Mac, and it clearly has issues. Fiona, I've got a circle on my screen, and
okay, I'll turn. Shall I turn your screen share off, and then you can turn it back again?
Yes, okay. Let's do that. Sorry, everybody. It's just a technical issue with Apple products. Fiona, let me know when you're done.
Yep, so.
Right. Okay. Can you now see my slides?
Yep.
Good. That's a relief. Good afternoon, everybody. In the next 40 minutes, I'm going to be taking you through a piece of work which I think is new, and I don't think it repeats anything that's been done before. And we're calling it the Operational Energy and Carbon Emissions Reporting Framework. And this is a piece of work that I've done while at the consultant WMEboom for Centre for Digital Built Britain, who are custodians of the government soft landings process, which we'll come on to very shortly, and funded through the Construction Innovation Hub. I don't really need to say much more about myself. Greg has already done so. That's what I do, and that's who I do it to. So I teach on the UCL Bartlett Masters modules and do a lot of soft landings work. If you want to get in contact with me, there's my email. So 2 phases of work. And what I'm talking to you today about is the phase 1, is the top one there, which is to identify when during a construction project information should be exchanged between the project team and the client's representatives for the emerging operational energy and CO2 emissions. Now, the key phrase here, which you've probably come across in other contexts, is digital twin. And a digital twin essentially is allegedly an exact digital creation of a physical entity. Now, when it comes to the modeling of operational energy, digital twin is not really a precise definition because, as anybody listening on to this webinar will know, energy analysis involves a degree of approximation and quite a number of assumptions. And those approximations and assumptions generate error margins, maybe of 25% or more, depending on the point in the project and the level of detail available to a simulation modeler. So we can say at this point that the operational carbon emissions, energy and carbon emissions digital twin possesses what you could call a given depth of reality. It can never mirror reality. So that is my definition of digital twin. We're not here to talk about phase 2, but if I get a chance at the end of this talk, I will do so. And the point of this particular project is to align to the needs of soft landings generically and the central government client version, government soft landings. Right, so I can't assume in this talk that that everyone listening in on this presentation is fully aware of what soft landings is. So there are 2 sentences which largely encapsulate what soft landings is. I'm not going to read them out. You can read them as quickly as I can. But the purpose, overall purpose, is to improve the operational outcome of the building, not of the construction process or the construction project team, the building, the asset. And we must remember that's what it's about. It's not about construction efficiency. It's not about design quality. It's not about cost effectiveness and timeliness. All those things are really, really important. It's about whether the building performs as intended in energy terms, in comfort terms, usability and manageability terms. So there is what we call the soft landings virtuous circle. And this is the opposite to the business as usual vicious circle that construction gets itself into. And there are now 6 stages to soft landings. We separated design and construction a few years ago, and that was a damn good thing that happened. And of course, the one bit that's missing from this circle is feedback to the next project. We have to learn from experience. And the whole point of this soft landings is closing the loop between client expectations, design intentions, and the operational outcomes, and learning from the experience. I might argue, and I'm sure I'm going to offend a few people here, by saying the UK construction industry is one of the very few, if not only, major industry that persistently operates in an open feedback loop. It almost tries not to learn from experience. And some would even claim the industry's insurers drive this culture in order to reduce risk. Well, if that's true, then why doesn't the same policy apply to the airline, automotive, and medical industries? Yeah? Construction operates in an open loop way, not because it reduces risks. We do it because our terms of appointments, our forms of contract, our regulatory compliance processes and payment practices promote and support an open loop culture. And that's where you get this vicious circle of underperformance, which we'll come on to in a minute. So soft landings is not a set of procedures. It's about caring about performance outcomes, not just in reaching PC and getting through defects unscathed, right? And it's important that this is expressed in the client requirements. It requires greater mutual understanding between all project members about what the project's performance objectives actually are, and it demands upon us that construction professionals conduct performance feedback to inform briefing and design and perform constant risk assessments of operational outcomes, or at least periodic rather than constant risk assessments. And of course, to use post-occupancy evaluation to tune up the building and understand what's going on. Now, just for those that don't know, soft landings as we currently know it was a joint published procedure by the Usable Buildings Trust and BSRIA back from 2009. And now it is enshrined wonderfully in the 2021 RIBA Plan for Use. And apparently it's going to become a RIBA members core competency. If you want to know about that, contact the RIBA. But in 2012, government soft lands decided they wanted something for the central government client. It was linked with building information modeling, and that was launched in about 2012. Now, this was written specifically for central government. It wasn't written for the public or commercial sectors, but nonetheless, it is being picked up, and I'll go through that in a second. There is a convergence guide from BSRIA, which I believe BSRIA still publishes, and if you need to know the difference between the two, just go and read that nice document written by Ashley Bates and Abhor Lee. There are loads of documents on soft landings. There's the framework, there's the government soft landings document you can get from Centre for Digital Britain, there's a plan of work, there's the latest plan for use guide, which I would recommend to you. And of course, there is CIBSE's TM61, it's rather solid guide, and it includes lots of soft landings related issues. So I'm not going to say much more. Those are the guides, go to them. But we still have a problem. We still have a problem with operational energy because we don't have visibility of the emerging outcomes as they as they emerge during the procurement and construction process. And we're not spending enough attention to energy loads and the modelling thereof after RIBA Stage 4, because Part L of the building regulations doesn't require us to do so, contract doesn't require us to do so, and the dynamic simulation models are run out of fee anyway. So things happen during procurement and construction to drive up the energy loads. And up until now, no one's bothered to sit down and work through the plans and works and procedures on government soft landings and soft landings for identifying when would be the optimal point to report the emerging energy emissions associated with that building. We need those data exchange points on operational energy and carbon. Now, for the sake of brevity, I've created an acronym, which I don't normally like doing, operational energy and carbon. We'll just call it OPEC. Yes, I am not. I am fully aware of the irony of the use of the word OPEC, but nonetheless, that's what we've called it for the moment. So that's where, if you see it, that's what it means. Now, this diagram usefully appears both in TM61 and the RIBA Plan for Use, and what it demonstrates is that we regularly overpromise. We go below the regulatory or client target line there on the performance factor scale on the left-hand side. We often try and beat that, but when we switch the building on, we discover it's actually an energy performance gap of anywhere between 2 and 3 and sometimes more. And there are reasons why that is. And there are no soft landings activities. So if you do actually recalibrate the model in year 1 of building operation, you're likely to find this disparity. We call this the performance gap. It's well documented, although I will give you a demonstration of it here. This is an academy building. Doesn't matter which county it is, they're all the same. And as you can see, the as-built EPC for regulated loads only was beating the target emissions rate. The scale on the left-hand side is TER in kilograms of CO2 per square metre per year. There was no, in this particular project, there was no as-built EPC for regulated loads, but it hardly matters. You know, you switch the building on and you end up with this massive overshoot on energy. And that's where this S curve comes from. It's a stylized curve, but we see it time and time again on building studies. And of course, none of this is covered by statute. You've got your planning permission, you've got your EPC. It doesn't really matter what the building does after completion. You're not going to be held to book for it. And although there was no as-built EPC, we know a highlighted column there, fourth from the right. These were it was a CIBSE TM54 energy analysis that looked at the procurement issues that were not covered in the as-built calculations. And there, it's not responsible for all the overshoot, but you can see it's responsible for a large proportion of it. Now, you can run a number of buildings through this and you'll get a similar kind of shape. Sometimes buildings do better, but often they're like this. So coming back to this diagram, the issue we have is that we don't know what's going on in the middle here because no one's keeping track of it. Now, there is a design for performance initiative which demands that we keep track of it. And of course, Passive House, the certified Passive House process also demands that you do it. But for the vast majority of projects, we do not have eyeballs on the consequences of things like value engineering or vandal engineering. We don't have what happens with what known as equal and approved specification changes and so forth. The other important thing to bear in mind that simulation modelers are not interested in unregulated loads and know very little about building performance. Their focus is on BRUKL reports and not much more. So there is no audit trail being taken by expert modelers who may actually be able to tune up the dynamic simulation model. They're very rarely involved. So lack of attention, lack of fee to do things properly. We don't sustain the skills needed to maintain energy and emissions during procurement. And as I said earlier, we have this construction culture and a reward structure that focuses on project delivery at the expense of out-term performance. This diagram is also in CIBSE TM61 and RIBA Plan for Use, and it shows a dotted line of a better approach where you're keeping track of the energy and emissions as you're going through the RIBA plan from stage 0 to stage 7, which now includes the soft landings process, the soft landings activities in the RIBA Plan for Use, there's still likely to be a rise in loads and operating hours, project substitution and so forth. But at least if you're keeping track of it, you can watch it and you can see what's happening and you can report it. And the project team can either accept the penalty or put in place some mitigation to reduce the impact, the negative impact of whatever is causing the energy uplift. And of course, if you're doing soft landings activities, later in the project, then you've got a chance to tune up the building, and you've got the error bars there, which are consistent with the TM54 approach. So yes, if you're lucky, you might get nearer to the design estimation, but most of the time you're going to be overshooting it a bit, but you're not going to be business as usual. You're going to be following the passive house design for performance mentality and doing something to tune the building up and to keep watch on the emerging loads, on the loads as they emerge. So the big question is, when should these reporting points be? Where should they be? How do they match onto our existing plans of work? So what data needs to be exchanged and when? Key question. Now, this is we've got a bit of a head start, because with government soft landings, this is a diagram you often seen in government soft landings documentation. It's not the most elegant diagram that's ever been drawn, but it does actually have 7, I think. Oh no, it's 8 reporting points. It doesn't say when they are, but it does identify 8 information exchange points. So the trick is, are these 8 enough? Are they equidistant from each other, or do they fit in some gateway process? So that's the problem. So the solution we came up with is to come up with a best practice structure for these data drops, information exchanges, but moreover, to define the gateway requirements for information exchanges. And that's where it starts to get a bit tricky. Ultimately, generate some free guidance and also generate a spreadsheet tool for this procedure that could be used. And that spreadsheet tool would be consistent with the procedures published by the CIBSE, notably TM54 and TM22. We'll come on to those 2 documents later. So what I did was assess the main plans of work and the procedures that most construction projects use, particularly those that are relevant to central government projects, NHS projects that use government soft landings, and in Scotland, documents like the Scottish Capital Investment Manual and so forth. Then the next trick was to identify the references to energy emissions reporting, sorry about the farmyard equipment going past my window, during procurement and post-handover soft landings aftercare requirements. Plotted the main measurement reporting requirements, identified the data drops specific to Scottish requirements or Scotland requirements, talk to simulation modelers about what needs to be reported and when, and liaise with institutions like RIBA to make sure it fitted with their requirements. We then wrote some assessment flowcharts, which I'll show you, some of which I'll show you very shortly. So those are the kind of 4 things we'll go through. Here's an arguable objective, or rather consequence of what we did. You either go down the dynamic simulation route, and of course companies like TAS and IES would say that's the best route to go, or you go down a spreadsheet route, or you try and do them both in parallel. Now, of course, doing things in parallel is not the most efficient or elegant way, but we have to recognize that the vast majority of projects do not have the fee and the capacity and the resources to maintain a dynamic simulation model all the way through. And actually a spreadsheet, an Excel TM22 style spreadsheet, probably the simplest and best way of keeping track of all the electrical loads, because it's mostly the electrical loads that increase. So you have, on the one hand, you have a dynamic simulation model, digital twin, and you would use this for modeling of thermal loads for BRUKL outputs, but mostly, certainly up to RIBA stage 4, you're only looking at regulated electrical energy and emissions. Run over here on the left-hand side, you can use an Excel spreadsheet for detailed analysis of all the electrical loads and import the thermal energy and emissions data from your BRUKL DSM if that's what you need to do. The big question is, are you going to keep the DSM running or are you going to shelve it? There are many reasons, and this is a slide that you can read as a PDF that Fiona will make available to you after this presentation. There are many reasons why energy calculations aren't done in DSM. And here they all are. And I'm not going to go through them. This is one of those slides you can read in your own time. But I've highlighted one, and that is you have to ask the question whether the DSM modelers that are working in consultancy are skilled enough on the operational performance factors, whether that's diversities or load profiles or wasteful and parasitic operation, in order to be able to model the emerging energy performance of a building accurately. And they're not asked to calculate those kind of things anyway. There is one from the third from the bottom, is that the more things that you try and model in a DSM, the greater detail that you try and put into that, the greater the number of margins of error on things like power densities and performance coefficients that start to build up. And the more they compound, the more the prediction or the calculations will be less accurate as those assumptions pile up. You know, arguable point. We can discuss this in the Q&A later. Anyway, there's a number of reasons why. Alex Tate, when we were discussing this with Alex Tate, who's head of technical practice at RIBA, came up with a wonderful quote. He said, "We need to incentivize the need to have the right kind of geek on board." Now, whether Alex is happy to be saying that, I don't know, but it was a very good quote, and he's absolutely right. And Passive House does that, and of course, Design for Performance will do that. But until those procedures are commonplace, you don't have the right kind of geek on board. So I looked at a number of key project plans and plans for use, and there they all are. I may have missed one. I hope I didn't, but there's the plan for use, the BIM framework, BREEAM, of course, government soft landings, and the BSRIA soft landings, BSRIA BG6, design framework for building services, very granular approach, and of course the requirements of various CIBSE technical memorandums. And there are 5 types of energy and carbon data drops. And the reason I'm showing you this slide now is so the one that follows makes a bit of sense. Anything that's mandatory is in red. That's essentially BRUKL and as-built EPC. Really simple. There's only 2 of them, generally. The intermediate ones I've coloured green, and they're the ones that link to gateways in RIBA, the BIM framework, design framework for building services, and so on. So it really links to this diagram in the RIBA Plan for Use and CIBSE TM61. Those are the green circles. Then you've got the specific requirements of the Scottish Capital Investment Manual and NHS Scotland, which are required to do business cases, and as part of the business case to look at the energy and carbon emissions outcomes of those buildings. And there are information exchange gateways laid down. And just to let you know, both the SCIM and NHS Scotland mandate government soft landings, so there's no way out of that. Then there's these dotted lines, dotted circles, which I did show earlier but didn't explain, and these are pre-gateway information exchange points, which are for projects where you have extended time and you might want to have intermediate data drops. So they are 3N and 4N essentially that occur prior to the gateway, and you might want to do a multiple of those. Anything which is a red dot is an intermediate data drop within government soft landings, because government soft landings has not separated design and construction in the same way as the BSRIA soft landings documentation more recently has. Okay. It's also worth saying that not all projects that use government soft landings use the RIBA Plan of Work. There are many highways projects or drainage scheme projects that are government soft landings, have to be government soft landings compliant, but wouldn't go anywhere near the RIBA Plan of Work. And then you have BSRIA's pit stopping reality checking process. Now, I mention this because it's, much to my surprise, mandated by the Scottish Capital Investment Manual, and it's also mandated for NHS Scotland projects. I'd like to know who it was that decided that. I haven't spoken to them yet, but making it mandatory is not what was intended when it was written. But anyway, let's not go down that particular rabbit hole. So you end up with a plan of work that looks like this. Sorry, a structure which looks like this. And I've layered them all, and we've got the RIBA Plan of Work at the top, well, just below the building regs. And as you can see, if you look at that, most of the gateways do kind of line up. You've got BSRIA BG6 here, which has a more granular stage 4 for feasible generic design, coordinated generic design, and coordinated specific design, which broadly sits under the current RIBA stage 4. But as you can see, you've kind of got to decide where these data drops appear. And when you put the data drops on this diagram, it looks something horrendous like this. Oh, sorry, I forgot there was an animation. What we have to remember is the Scottish Capital Investment Manual has 4 stages where you go strategic, initial, outline, and full business case. And if you look at it, the full business case occurs or ends, the gateway ends at RIBA stage 4 when the technical design is being done. So there are lots of other activities for Scottish Capital Investment Manual projects which one has to fit into. Sorry about that, I forgot about the animation. So the graphic looks like this. Now, all you really need to know here is the vertical lines are the gateways, the red dots are intermediate, and anything which is a dotted circle down below is where you're saying this is where you might want to put intermediate reporting points in. So over on the left here, these data drops here are largely for government soft landings and Scottish Capital Investment Manual NHS projects. That is a mandatory requirement, even if you wouldn't do it on a standard commercial project. Over here, you've got the intermediate data drops for projects which have, a long period of design and construct, and you might want to put multiple ones in. But as you can see, they broadly fit with the design framework for building services. And over here, of course, you've got the new stage in the RIBA Plan for Use, which is the RIBA Soft Landings interpretation. And that is the post-completion energy assessments that you do up to 3 years post-completion. So it's a hell of a slide to present at a conference, but it broadly works. So that's good news, right? It's the data drops broadly line up. So there's nothing inconsistent, there's nothing that is clashing. And that was good to know. When it comes to the spreadsheets, when it comes to the guidance that's going to underpin this, we drew a number of flowcharts that say this is what's required at any one moment in time. And the guidance is going to contain these flowcharts. Now, in this presentation, I am not going to go through every flowchart in great detail, but you can kind of see in this particular one, RIBA Stage 0, there may be, if you're working on a phased program of work, or you're working on with a client with whom you work regularly, it may well be that even at stage 0, there may be some early modeling and studies done by the client. And that early modeling studies may actually take into account the client's overall carbon targets. And in the act of doing that, you're informing the client's strategic aims and business case development, which brings us back to the Scottish Capital Investment Manual and its requirements. So for many projects, you wouldn't be doing this. There wouldn't be an appointment at RIBA Stage 0 necessarily that would involve this, but on certain projects, it would. And it would lead to early concept thermal performance, spatial areas, and volumes. Now, the reason I show this flowchart is actually for the blue boxes, because what you need to be doing is identify, are there any process loads? What are the hours of use and the energy costs that are likely to be incurred? And what feedback from existing assets do you have that might inform how this building might be required to be designed for that particular client? So these flowcharts are giving you clues about what should be put into the digital twin when you create it. Now, when it comes to government soft landings and the Scottish Capital Investment Manual specifically, this is the business planning side of things. You need that data drop 1A for the orange boxes on the left-hand side. And that goes into the outline business case, which then feeds into the full business case later on. And that's the GSL-based client requirements. So you've kind of got this kind of notional digital thread items from the client that would go into the building information model. It may be that your feedback from existing assets needs to go into a separate data drop and be captured somewhere in the building information model. And that, of course, for those of you that are aware of the RIBA Plan for Use, that data drop fits with the RIBA Plan for Use requirements, as I showed you earlier. So I've tried to make these flowcharts consistent with existing guidance and with existing requirements. Now, as I say, I'm not going to go through these flowcharts in great detail. You'll have them in the PDF. They will also be in the printed guidance with all the words that attach to them. But it does get complicated, because if you're going to have a parallel digital twin, the electrical side in a spreadsheet, and the dynamic simulation model doing the detailed thermal, then although there's going to be detailed electrical on the left-hand side, and BRUKL and thermal inputs on the right-hand side, and along the top, the main or universal input, shall I say, that go into both. But on the left-hand side, if you're doing BRUKL in RIBA Stage 2, then you're really looking at NCM model calculations. You're looking at environmental inputs and weather. On the left-hand side, on the electrical side, you're looking at detailed diversity and magnitude factors, and the BPE evidence would go into that. I very much doubt that simulation modelers working in a DSM on the right-hand side, who are focusing on the BRUKL report, will be handling BPE feedback evidence and being able to do those diversity and magnitude factor calculations. I'm sure there are people at IES and TAS would disagree with me, and there's probably some simulation modelers out there that would disagree with me. But in general terms on projects, this is the reality. You're doing two things separately in parallel. Either way, they output to data drops, and either way, they output to inputs to building information model, particularly if we're working on a government soft landings project. And of course, you're generating a preliminary BRUKL. When you get to RIBA Stage 4, again, the boxes are very similar, but obviously on the right-hand side at RIBA Stage 4, you're looking at seasonal thermal diversities and climate change adaptation. If there are any changes to the DSM after you've generated a BRUKL, or up until that point, certainly, you're looking at more detailed weather files, maybe, or updated weather file. But the critical sensitivity analysis on the loads, which are the red boxes, this is the sensitivity analysis that often doesn't get done, particularly on operating hours and particularly on control and management factors. And there may be people listening to this presentation say, oh, yes, well, we do that. Do you really all the way through? I very much doubt it. You have to go looking for data on changes to occupied and out of hours use. You have to go looking for information about unregulated loads, and you have to really assess the difference in changes in control and management if the contractor has decided to go with a different control supplier, for example. Now, the Scottish Capital Investment Manual actually calls for an energy dynamic simulation model for the full business case. So it asks for that up until RIBA Stage 4. So it's worth bearing that in mind. And to quote the Scottish Capital Investment Manual, they are asking for, and I quote, accurate thermal and energy model. Oh, and soft landings. What is accurate in this context demands debate, because as we know, all estimations come with margins of error. Accuracy is a moving target in itself. So when you get to RIBA Stage 6, here's a big question. Are you running the digital twin, the dynamic simulation digital twin, or has it disappeared? If it's disappeared and it's no longer being run, then you're focusing on the digital twin that you've created in the spreadsheet, which will have imported the last known thermal calculations in the DSM. And of course, you won't be able to import the thermal envelope calculations and any seasonal thermal diversity factors. That will just go straight into the as-built EPC. It won't go via the DSM. And similarly, any commissioning test data has nowhere to go except into any analysis that's being done outside of a DSM, and as I'm suggesting, in some kind of spreadsheet. Because you still need to keep track of your diversity and magnitude factors, particularly for things like actual specific fan powers, not what was assumed at design. And a lot of skill is required on the left-hand side of this diagram. A lot of skill, and I question whether that skill exists to the degree it needs to if we're ever going to meet our net zero carbon targets. At RIBA Stage 7, you may well have a DSM. If you do have a DSM, then that's fine. That will be the final model for the building information model, or it might even export to an Excel digital twin. If you've got your Excel running, then you're still revisiting your diversity and magnitude factors. But also in RIBA Stage 7, which is the first stage of building operation, that's when the soft landings team will be gathering data during the defects period to keep a watch on the energy costs, and must be observing the initial control and management practices that are occurring in the building, because this is the early assessment on the actual loads, operating hours, and control factors that are operating in the building. And you may have a post-handover review pit stop before you hand over to the asset managers, who, if they're going to be managing the BIM, will then take that on, or take on the spreadsheet that you've created. Just one word of warning: doing early assessments in the first period of soft landings is not post-occupancy evaluation. It's data gathering and using your eyeballs to see what's going on. Do not fall into the trap of judging a building during defects. That's madness, I would say. So RIBA Stage 7, this is in the second and third years. One assumes there is now just one digital twin, whether it's a DSM or whether it's a spreadsheet, hardly matters. And the soft landings aftercare team in the red boxes are now tracking that. And they're also tracking the effects of seasonal commissioning and any annual formal post-occupancy evaluation that's carried out. So I have taken through those flowcharts in great detail, and I've just highlighted there. You've got to bear in mind, of course, post-contract fit-out changes, which can change things. You know, server rooms, they can add electrical loads without you knowing. So I have raced you through those flowcharts, but the guidance that will be published will take all that into account. So what energy analysis and reporting methods have we already got? Well, we got CIBSE TM54, but that's not a tool, remember. That's a set of procedures published by the institution, and consultancies, designers, they develop their own bespoke spreadsheets and formulas. And those outputs aren't necessarily transferable to third parties or the building operators. They may be commercially confidential to whatever consultancies created them. Now, if consultancies do hand over their TM54 calculations or their spreadsheet, then fine. But I would suggest that many of them do not, because they're corporate and bespoke. We have CIBSE TN22. The 1999 version is pretty basic, but it's functional. I have to say, in my experience and the experience of the person that authored it, the 2006 version remains rather buggy. It's certainly outmoded. It's still published. I personally can't recommend it. That's another story. And of course, people say we have, there is a 2014 version that's published for Innovate UK, but CIBSE never adopted it. Well, rightly or wrongly, that's the fact of the matter. We do have Carbon Buzz. I don't know if any of you know, it may well be operational as a website, but the software is totally moribund. As far as I know, it's not being supported nor maintained, and that's been the case for the last 5 years, unless a delegate listening into this presentation can tell me otherwise. So what we have done in order to help these energy and carbon data drops, we've developed a free downloadable 22-style spreadsheet, which is designed to track electrical energy and emissions during procurement and construction. Just like TM22, it's a single line entry. You've got to import the thermal loads from DSM, and this spreadsheet will generate kilowatt hours a square meter, the cost of energy and emissions and CO2. The beauty of this spreadsheet is that it's been written with macros that enable you to maintain an audit trail of any changes that you make using just one spreadsheet. So that's, with optioneering, spec changes, value engineering, changes to hours use, and so forth. So you've got an audit trail that enables you to capture those emission savings or penalties as they emerge. It has an energy metering sub-metering module. It's just a nice to have. And the important thing here is that this spreadsheet has been made GSL and Scottish Capital Investment Manual compliant. In other words, it will deliver accurate energy and thermal modelling. And the spreadsheet was drawn up by John Field, who authored the original TM22, and I added a bit of input and top and tailed it for this purpose. So good old John. Now, presenting you with how to use a spreadsheet that you've never seen before is a rather pointless exercise, but just a couple of slides just to show you broadly what it can do. You enter data into the red boxes. It's pretty straightforward. Floor areas, tariffs, hours of use, and so forth. You then have an energy loads table, which is a single line entry, which I'll show you in a second. That outputs to, they will auto calculate secondary results of power demand, total watts at full load, in use winter and summer, average power demand, and so on. It calculates those things automatically. And you've got toggle buttons in this spreadsheet which enable you to make a change and capture the change. And when you do, it looks a bit like this. This is a blank sheet. So there you are, single line entry, really easy. You put your load in, you select the item from the drop-down menu, how many bits of equipment you've got, is it rated watts, is it watts per square meter, and it calculates. And here's the beauty. Once you've started making changes, it captures them. So here's a mock-up of that. So changes have been made to half a dozen loads there, and the spreadsheet will automatically highlight the change that you've made and put a color code to it. So it captures it in the spreadsheet. You can batch it. You can do a whole batch there in green, and you can say, I'm going to change the load factor out of hours for a whole load of lighting systems. As I say, it captures it. And the great thing is it's got this track changes table in it. So every change you make, it will itemize it and say, change A, you change this. This is the saving or the penalty in CO2 and cost. And it goes through and it captures it. And it then also will give you an output table, summary output table of those changes. And you can associate it by submeter if you wish. It's not mandatory, but you can do that. So which then gives you a submeter table, and you can start to keep track of what the submeters should be recording when the building is switched on. So that is a bit of a gallop through a spreadsheet that you've never seen. But the beauty about this spreadsheet is no matter how many changes you make, the spreadsheet never gets any bigger than a megabyte, which is ideal for when you're doing, analysis and calculations on the hoof, or you want to hand over a fully finished spreadsheet to an asset manager to take it on from that point on. You're not talking about, gigabytes of data in a dynamic simulation model. You're talking about less than 1 megabyte. So it's a bit like TM22 on steroids. That's the way I'd look at it. So this explanatory guidance is going to be generated. We're going out for a bit of peer review, and that is occurring at the moment. So we're very close to publication on this material. So we'll generate some explanatory guidance. We'll generate flowcharts for each information stage gateway to explain what information is required at each stage, and I've showed you those flowcharts already. We will make an open source EM22 style operational energy and emissions tracking spreadsheet available, and we'll generate some user guidance for that spreadsheet. So I've kind of repeated myself there. The guidance will be published by Centre for Digital Build Britain and Construction Innovation Hub. I'm hoping there'll be some awareness raising, training and support webinars, that kind of thing. And at the moment, we will be dovetailing this work with the current revision of BS 8536, which hopefully will reference the RIBA Plan for Use as well. I haven't got time to get into the phase 2 project. That's for another time. But just for the record, we are going to develop a trajectory-based visualization of operational energy and carbon factors, which will then fit with what I've just demonstrated to you. So the guidance will probably look something like that. And the spreadsheet guidance will probably look something like that, like you normally get with this kind of spreadsheet instructions. And if you want to know more about the launch details of this project, then there's an email to contact engagement@cdbb.can.ac.uk. And just to be clear, CDBB is the custodian for government soft landings. And I think that's it. So I managed to fit it in within 50 minutes. I hope I've kept delegates listening to me all the way through. Sorry if it's a bit of a gallop. I'm happy to take questions from this point on. Fiona.
Okay, thank you, Rod, for that. That's a lot of information there and a lot of stuff to take on board.
Yeah,
and
a lot of stuff.
I've fortunate enough to have been sent the presentation, so I think a couple of people have said it's difficult to see. Once you get the presentation, you're better to see all the detail. There's a lot of information there.
There is. I wrote it. I wrote it so people could see the PDF and use it afterwards. Sorry.
Yeah. So it's can read it and digest it. So okay, the question that come through, which I'm going to read first one, is from Steve Rufus in Dorset, and he's asked, has the use of government soft landings methodology helped to reduce the performance gap?
Steve, I'd like to be able to answer that one, but sadly, there is no mandatory reporting of government soft landings outcomes anywhere, as far as I'm aware. It should do. I would say if you know of a better game, please tell me. But if projects are doing soft landings properly and not paying lip service to it, and the project team is focusing on the operational outcomes and actually staying engaged after handover and running for at least 2 years, if not the third year, then there should be evidence from those projects that government soft landings is having an effect. The problem with government soft landings is it wasn't written for the public sector broadly. It was written for central government clients, and GSL demands leadership by clients all the way through the project. If that leadership isn't there, I would question the success of any GSL project, of a GSL project where that leadership isn't there.
Okay, thank you. Next question we've got is from Philip Jordan, and he asks, please, at what point in the design process are saying that this OPEC should or can start?
It should start from the very beginning. I mean, it's not inconsistent with existing energy reporting requirements, particularly for BRUKL. What it does demand is more information, particularly on unregulated loads. And there are obviously the early stages of design, the information on unregulated loads. If you're doing anyone who's listening in on this presentation who's ever tried to do a CIBSE TM54 will know the margins of error that you have to apply, which can be something like 25% in the early stages. But it shouldn't stop you at least starting the process. So once the process has been started and the project team has bought into it, then, and there's fee to do it, and I do appreciate there's a little bit of fee that will be required to do it, the trick is then to sustain it throughout procurement and not lose sight of the importance of tracking energy, operational energy and CO2 emissions, rather than them becoming a surprise when you switch the building on. I don't see how can there be an argument for the latter.
Okay, thank you. Nicola Booth is asking, do you think that the changes to Part L will encourage the use of building monitoring in comparison with the as-built modelling, and therefore encourage more accurate approaches to energy modelling?
If you're, I'm going to assume that the questioner is talking about the forthcoming changes to Part L, and I would say no. I don't. I'm very disappointed in the Part L. I can't remember the name of the document, but there's a future planning document which talks about introducing measures to tackle the performance gap in 2025. I'm just astounded by the lack of action from communities and local government on the Part L revisions. So I'm afraid I may be other people listening in that have greater faith in the latest update of Part L. I have no faith in it at all. It should be tackling these things now, not putting them off until 2025.
Okay, thank you, Rod. Philip's come with a question. What's being shown is seemingly for new build, whereas given the critical time we have left to meet carbon reduction and the ratio of new build to retrofit, there's surely a need to do an OPEC version for retrofit.
Oh, well, I would say it's easier for retrofit. I'm happy to be corrected, but I think it's easier for retrofit because the client already has the building. The building exists. You have historical data on what the building is currently doing. You know what, you hope if it was a more recent building, you may even have some digital record of that building, but at least you've got the physical entity in front of you. You can go and construct it in a simulation model and start playing tunes with passive solar measures and insulation measures and so forth. And of course, you're stuck with the orientation. The orientation ain't going to change. The massing isn't going to change. So I don't think it's that refurbishment is makes it more difficult. I think it's, if anything, it's slightly easier. It just requires. I think it's just a matter of to what depth refurbishment is going to take place. How are you taking it back to the shell and core, or is it a light fit out? But I take the point from the questioner that there probably needs to be a recognition of the requirements for refurbishment compared with new build.
Okay, Nicola's come back and said that she agrees it needs more commitment. It's shocking.
It's shocking.
I think we're all probably in agreement with that. Steve Roof's come in and asked about non-regulated energy seems to play a big part in the performance gap. Very good to see a one-stop spreadsheet to try and track these details, and they've made the comment that I feel that Part L and regulations need to target these areas.
Yes. Well, until we get compliance at completion, or compliance in building operation, if we're never going to shift from compliance at design, then the construction industry has no motivation to operate in a closed loop structure unless you really want to do it, unless you see it as part of your professionalism to do it. But if the regulatory process demands compliance at design or compliance RIBA stage 3 and 4, then it's always going to be voluntary, which is shocking given the net zero obligations that are placed upon us. You cannot have net zero on obligations on the one hand and compliance at design on the other. There has to be compliance in building performance in use, and until such time as the regulatory process wakes up to that, I fear we're always going to be behind the curve.
Okay, a question's coming from Declan. He's asking, communication between client, contractor and designers is key, and soft landings is obviously grown from that since the late 1980s. How do we encourage clients to negotiate their contracts through soft landings to avoid complicated KPIs that may hinder good contracts over those who may not bid in the frameworks, etc.?
Ooh, that's a big question. There's a lot going on in that question. It's
not the easiest to read either.
It's a good question. I'll be like Humphrey. It's a Humphrey in Yes Minister. It's a very good question. I think the problem there is that clients need to engage with their projects all the way through. And if you've got an engaged client and you've got an expert client, you're more likely to get that. But there are so many lay clients that don't know what is required of them and are happy to hand over the project to the main contractor on a design and build and then walk away and just wait for the building to come out the ground. And I agree with you, and particularly with government soft landings, there is this concern of excessive KPIs, excessive forms of measurement. And I think it frightens the construction industry. It doesn't necessarily engage. So whatever targets there are need to be revisited, and they need to be revisited by the client, particularly if loads are increasing for whatever reason. Hours of use particularly, because it's not the kilowatts that matters most of the time, it's the kilowatt hours. It's the hours that drive up the consumption. And therefore we need to keep a watch on the hours of occupation and need to keep a watch on the causes of wasted energy and parasitic operation and wasteful operation. I don't know if this is still the case, but when I was studying schools, about 40% of the energy consumption of a school occurred when there was nobody there. If you want to see a school consume energy, go in on 11 o'clock at night on a Saturday. That's when you see things on. So we need to keep a watch of the hours, and the clients need to know that. They need to take responsibility for their hours of use. It's no good just focusing on the kilowatts. But I mean, there's a big question I've just been asked, and to which my answer is yes. Yes.
Yeah, good housekeeping is, it may be very basic, but it's got a lot going for it, hasn't it?
Yes,
regarding building operation. Just a question that I've got, Rod, is where in the world do you think are leaders in this kind of work of actually getting buildings to deliver and perform?
Yes, they are not. You could argue they are the people who adopt Passive House. You could say now Passive House is a product, okay? You buy a product, but it's the belief in the Passive House way of thinking. It's those who truly believe in design for performance. And I use design for performance both to reflect that's the Australian National Australian Building Environmental Rating Scheme, NABERS, which is now operating in the UK. It's the people who honestly believe in that and act as true construction professionals. Those are the ones who are going to drive this. But unfortunately, I think they're in the minority because our forms of contract and our forms of appointment militate against that on a broad scale. I think we do need leadership from communities and local government, CLG, Department of CLG. We do need Part L to be thoroughly overhauled and change its focus entirely. But we are relying upon a few leaders in the industry. And there are a lot of leaders in public authorities, local authorities, yourself included, Greg, who believe in this stuff and want to promote it, but find yourself trapped by cost limits and limitations on budget and on time, and not enough support from central government, and not enough support from contracts writing organizations and so on that will enable you to achieve your net zero obligations, which I know that you have. All local authorities are trying to write their net zero obligations and deliver net zero obligations with the tools that they had in their toolbox 20 years ago. And it's terrible to see that kind of pressure, people trying to do the right thing under that kind of pressure. The leaders are key architects, I'm not going to name them, they know who they are, key consulting engineers, and even some contractors who truly believe in this. But they are in the minority. I'm not quite sure how we turn them into the majority. It has to be a regulatory requirement.
Okay, Rod, I think looking at the time, that hour's absolutely whizzed past. Thank you so much. I'd like to thank everybody for attending this webinar. It wasn't exactly the most soft landing when we started, so it was a bit of a bumpy start, but I think we've gone through and hopefully got a soft landing towards the end. I'd like to take the opportunity to thank Rod for his time, our sponsors, Atkins, Faithful and Gould, IES, MPS Group and Wilmot Dixon for their support. Please, could you now just take a few seconds and answer the feedback question on the screen? On a scale of 1 to 5, with 1 being poor, 5 being excellent, how would you rate this webinar? A reminder also that all webinars over the 2-week period are being recorded and will be loaded to the Spaces YouTube channel. Delegates and Spaces members will be sent a link at the end of the conference. These recordings are only available to delegates and Spaces members. Thank you so much for joining us today, and I hope you have a great evening, and see you maybe at the other presentations that we've got coming up for the rest of the week. Thank you.